Here we have an example. Consider the polynomials px, qx, and r of x in P2. Recall that P2 is a space of all polynomials with real coefficient and the polynomial in x with degree at most 2. So degree is a maximum term. Here, for example, here is 2, so degree at most 2. And sometimes we denote this space by R2 of x, so space of polynomial real coefficient in x with degree at most 2. Okay, and we need to check whether they are linearly independent or not. So always we will start with the combination and check whether the equation linear combination equal to vector 0 has trivial solution or not. Consider, say, ax, a is p of x, plus b q of x, plus c r of x equal to 0 in this vector space. So 0 in this vector space is 0, 0x, 0x squared. For a, b, and c are scalar, in this case a real number. So what we replace px, qx, and r of x by all the three polynomials. So we have this is a times p of x, b times q of x, c times r of x, plus c times r of x equal to the 0 polynomial. Right. Okay, and then this is actually equivalent to, say, star is equivalent to all the equation above, which is equivalent to this one, and now we put them in terms with, say, scalar is a plus 3b, that's all for scalar, right? C a plus 3 times b, and then coefficient of x, so 3 of a, 3 times a, 1 times b, 2 times c of x. So a times 3 of x, b times 1 of x, c times 2 of x, and the last one 2 times a, 2 times b, and c of x squared, right? And this equal to the right hand side. And now two polynomials are equal if the corresponding coefficient is equal. This is equivalent to a plus 3 times b is 0, 3a, b, 2 times c is 0, 2a, 2b, c is also 0. So now we have a system, 3 equations, 3 variables, right? And this is, now we solve it by Gauss elimination, for example. Augmented matrix. One, 3, 0, 3, 1, 2, 2, 2, 1. This is our augmented matrix. So look at 1, 1, 3, 3, 0, 0, so 0 C, right? 3, 1, 2, 2, 2, 1. Okay, this augmented matrix. So one way, we have 3 by 3 matrix, right? You can just compute the determinant and we check whether the determinant is non-zero or not. And second way, we just do Gauss elimination. Now we can do Gauss elimination here. And the first step would be row 2, 3 times row 1 in row 2, and we also have row 3, 2 times row 1, row 3, 1, 3, 0, 0, 1 minus 3 times minus 8, 2, 0, 2, minus 4, and 1. And the last part, row 3 minus, or row 2, we can do row 2 minus 2. Or it's the same, row 3 minus a half of row 2. Row 3, 1, 3, 0, 0, minus 8. We can also put, or we don't even need that, just put minus 8. We don't need to reduce it. 2 and 0, 0, 0. And you see we have a rows contain all 0. This means that this matrix is singular, right? Determinant we know is 0. So therefore, this matrix is singular. Therefore, this system has infinitely many solutions, right? We know this is an infinitely many solution. And in particular, it has non-trivial solution, right? And it's by definition, if this equation has non-trivial solution, this means the 3 vectors, say px, qx, and r of x, are linearly dependent. I can say which is this says it's linear dependent. Yes, so whenever you have here's singular matrix, then you know that in this case determinant 0, we can say this they are linear dependent.